So moving on, objective 3. We're going to graph linear equations of the form y equals b or x equals a. We can rewrite certain equations like y is equal to -4 into 0x plus y is equal to -4. Or something like x equals 3 into x plus 0y is equal to 3. When the coefficient of x or y is 0, the graph is a horizontal or vertical line. Zooming in a little bit here. So horizontal and vertical lines. The graph of y equals b, where b is a real number, is a horizontal line with the y-intercept 0b and no x-intercept, unless the horizontal line is x itself, or is the x-axis itself. This would be at the origin. So examples, y equals 5 and y plus 2 is equal to 0, which we would just rewrite as y equals -2. The graph of x equals a, where a is a real number, is a vertical line with the x-intercept a, 0 and no y-intercept, unless the vertical line is the y-axis itself, meaning the only place that would be true would be at the origin. So examples, x equals -1 and x minus 6 is equal to 0, which we just rewrite as x equals 6. So we want to keep the following in mind regarding x and y axes. The x-axis is the horizontal line given by the equation y equals 0, and the y-axis is the vertical line given by the equation x equals 0. A word of caution, the equations of horizontal and vertical lines are often confused with each other. The graph of y equals b is parallel to the x-axis for when b is not equal to 0. And the graph of x equals a is parallel to the y-axis for when a is not equal to 0. Easiest just to remember that when you want to graph a y-intercept, that is a straight line, it's horizontal, and an x-intercept, that is a straight line, is going to be vertical. So let's go ahead and graph some. So we want to graph y is equal to -2 and x is equal to 1. So let's go ahead and we're going to say that y equals -2 is equation 1 and x equals 1 is going to be equation 2. So starting with equation 1. If we have equation 1, we can rewrite this as 0x plus y is equal to -2. But since we have 0 times x, we know that the only value here that matters is our y is equal to -2. And y is equal to -2 in this case is our y-intercept, which we find at 0, -2. Since this is our y-intercept and our equation is just that y is equal to some number, that means it is a horizontal line. Now for equation 2. X equals 1, we can rewrite as something like x plus 0y is equal to 1, which just ends up telling us that our x-intercept is found at 1, 0. And because we have no solution for y, or really infinitely many solutions for y, this means we get a vertical line. It would mean that no matter what value we plugged in for y, x would always equal 1, or no matter value we plug in for x, y would always equal -2. So these would create just straight lines, either horizontal or vertical. So let's go ahead and graph them. So our horizontal line is at our y-intercept, and our y-intercept is at -2. It's at 0, -2. So we want to go ahead and find the spot on our graph. Our x value is 0, so we start at our origin, and we track down till we reach -2. And this is our 0, -2, or our intercept. And this is the graph of our solution. Okay, it's supposed to be straight. It's a little crooked. There we go. So this is our horizontal line. This represents all of our solutions to our equation y equals -2. And now for equation 2, which was x equals 1, we want to find x equals 1 on our graph. We know this x-intercept is at 1, 0. So we start at our origin, we track to the right to find our positive x equals 1. And I just realized what I did, so I'm going to move this over here. So we have our x-intercept here, 1, 0. So we say 1, 0. This is the x-intercept. And we now draw our vertical line. And these would be our solutions in this case, or our graphs of our solutions. So this is what you would need to do when you are just graphing parallel and horizontal lines that are going to correspond to x and y intercepts. So a summary of the forms of linear equations from this section. So forms of linear equations, we have ax plus by is equal to c, where a, b, and c are real numbers not equal to 0. And when we want to graph them, we find any 2 points on the line. A good choice is to find the intercepts. Let x equal 0 and find the corresponding value of y. Let y equal 0 and find x. As a check, find a third point by choosing a value for x or y that has not yet been used. So then our example graph looks a little something like this. If we have that ax plus by is equal to 0, this means that our graph is going to pass through our origin or the center. So the graph passes through 0, 0. To find additional points that lie on the graph, choose any value for x or y except 0. So our graph would look a little something like this. We see in this case our x-intercept and our y-intercept would both be at 0, 0, so you would need to find additional points. For y equals b, we draw a horizontal line through the point 0, b. And when x equals a, we draw a vertical line through the point a, 0. So we see these images of our example graphs. Then lastly, objective 4, we want to use a linear equation to model data. So we're solving our following problem. We say that the weight, y, in pounds of a man taller than 60 inches can be approximated by the linear equation y equals 5.5x minus 220, where x is the height of the man in inches. For part A, we want to use the equation to approximate the weights of men whose heights were 62 inches, 66 inches, and 72 inches. Part B, we want to write the information from part A as 3 ordered pairs. For part C, we want to graph the equation for x is greater than or equal to 62 using the data from part B. And part D, we want to use the graph to estimate the height of a man who weighs 155 pounds. Then use the equation to find the height of this man to the nearest inch. So let's go ahead and begin. So for part A, we're using the equation to approximate the weights of men whose heights are 62 inches, 66 inches, and 72 inches. So our equation here is y equals 5.5x minus 220. And let's do what we did before, and let's mark each one of these values. We're going to say 62 inches is 1, 66 inches is 2, and 72 inches is 3. And what we can also do is we can also create a table. There we go. We have 3 values here. So you can plug in these 3 values. And we're going to say that x is our inches or a height. So height, which is x, and weight, which is y. And the values that we're choosing are 62 66, and 72, which is corresponding to 1, 2, and 3. So let's calculate these. So starting with our first calculation, we are going to plug x, or we're going to plug in x equals 62. So into our equation, y is equal to 5.5 times 62 minus 220. 5.5 times 62 is going to be 341 minus 220, which is going to give us 121. So our weight is now 121, and our weight is in pounds, height is in inches. Now for our second value. Now we're going to do 66. So we'll plug in x equals 66. So y is equal to 5.5 times 66 minus 220. 5.5 times 66 is going to be 363 minus 220, which gives us a value of y is equal to 143. So we want to fill this in our table as well. Then lastly, which we're just going to put this right under here, we want to plug in x equals 72. So we have y is equal to 5.5 times 72 minus 220. 5.5 times 72 is going to be 396 minus 220, which gives us the value of y equal to 176. So we found our x and y values that correspond to height and weight. And for part B, we just want to write this information as 3 ordered pairs, which we know since we created our table. Since our x value was 62 and our y value was 121, our first ordered pair is 62, 121. Our second ordered pair would be 66, 143. And our last ordered pair would be 72, 176. So we have 3 ordered pairs, and we want to graph this in the graph we were given for part C. Part C, we graph the equation for x greater than or equal to 62 using the data from part B, which 62 is our lowest x value. So let's go ahead and graph these. So our first value is 62 and 121, and we're going to zoom in here because the graph is a little small. So we find our value of 62, which if we look at our x-axis here, we see that each one of our vertical lines is identifying the next value in 2. So we had 60, 62, 64, this is 66, 70, and this last value is 74. So we can fill those in if we like. And we see that our y-axis is portioned by 10, starting at 120 and going to 180. So our first value was 62, 121. Now we're not going to get them exactly correct because of the portioning out here of our graph, but we can try and get as close as possible. So we find 62 on our graph here, and we go up to 121, which we're going to estimate is about right here. So this is, we're just going to write 1. We're going to write the number it corresponds to. Then 2 is 66, 143. So we find 66 on our x-axis, and we track up to about 143, which is we're going to say is about right here. This is 2. Then lastly, 72, 176. we find 172 on our graph, sorry, 72 on our x-axis, and then we track upwards to 176, which we're going to say is about right here. This is 3. Oop, 3. So we plotted our ordered pairs, and we can go ahead and draw a line through it. And this, ooh, not a good idea. Our line here doesn't seem to want to. It really seems to want to pick spots here. Ah, here we go. All right. So we see our points are about correct through our line. So last part D, we want to use the graph to estimate the height of a man who weighs 155 pounds. Then use the equation to find the height of this man to the nearest inch. So now what we're doing is we are identifying this spot on our y-axis and tracking backwards to our x-axis. So we're estimating 155. We're going to say it's about right here, 155. So we want to track over to our line and find the point on our line. That's about 155. And find the x value, which corresponds to 68. So our estimation for part D, which we're going to write right here, part D, our estimation is about 68 inches. This is what our graph is telling us. But then we want to use our equation to find the actual height of this man to the nearest inch. So if we use our actual equation, which was y is equal to 5.5 times x minus 220, we're going to plug in 155 for x. Sorry, for y. Then we have 5.5x minus 220. And now we're going to solve for x. So we're going to go ahead and we're going to add 220 to both sides. So we have 155 plus 220 is equal to 5.5x minus 220 plus 220. Adding these values together, we get 375 is equal to 5.5 times x. So we divide by 5.5, which in this case, using a calculator, we can divide out, and we get 68.18 is equal to x. But according to our question, we want to round to the nearest inch, which in this case would be about 68 inches. So our estimation was correct. So that is how we would go about solving more of this applied problem. So all right, that wraps up section 3.2, and I'll see you again for section 3.3.